The most important thing in science is let the kids do it. It's hands-on. It's the best way to learn science. So get your hands dirty and get in. So here they are. Okay. Welcome to Science in the Valley. I'm Jim Kleiber, and today we're at the Franklin County Technical School, where we're in the cosmetology department, where Miss Lynn and her students are going to be learning about pH. What is it? How does it affect your hair? What do they need to know? You want to learn a little more? Watch the rest of the show.
Real quick.
Okay. Hi, I am Miss Lynn. I am the cosmetology instructor at Franklin County Technical School. And this is a visual of the hair and its structure. The outside layer is called the cuticle, which, as you can see, looks like scales. When it is hot ironed or flattened, that's why it becomes shiny when we close the cuticle with a straightening iron. The inner part of the hair, this is called the cortex. This is pigment, these dots here. This is where all the melanin and the color of the hair is in the cortex. This is where all the action happens. Like if we perm, the cortex is what is compromised. When we color, that's the cortex is involved. This middle part is called the medulla, which not everybody has a medulla. Coarse hair does, fine hair would not have. So there's 3 layers: your cuticle, your cortex, and your medulla.
Lynn, can I ask you a question?
Yes.
Today we're talking about pH. Now, in pH, it's basically acids and bases. So my question is, if this is subjected to an acid, what does it do?
The acid would close the cuticle. An alkaline opens up the cuticle. So the color would have alkaline, perms would have alkaline. So that would penetrate the cuticle to get to the cortex.
So you want it alkaline, so that opens up.
Yes.
Opens
It
this
has
up.
the hair swell.
And what are these called?
This is the scale. It's like your outer layer of your hair shaft.
Yeah, the scales. So you put in a base to open those up to get the color in.
Yes.
And then you have to close them up?
Yes.
Now, so then you put a base and then you put an acid?
Like a conditioner, it would close the
Would
cuticle.
close that up.
Yes. And like in perming, the alkaline solution would open up the cuticle to get to the cortex. The neutralizer, which is called a fixative, closes the hair. So the perm solution breaks down the hair, forms around the rod, and then you rinse, and then the neutralizer closes the hair and keeps it in that formation. That's how it works.
Wow, a lot of chemistry
There
in
is
this.
chemistry.
There you have it.
Absolutely.
From Lynn, cosmetology instructor at Franklin County Technical School. Welcome to Science in the Valley. Here we are at Franklin County Technical School with Miss Lynn and her cosmetology students, and today we're going to be learning about pH. pH is kind of an important thing. I just learned that pH has to do with the hair, and I'm trying to remember if I get this straight. You can correct me if I get it wrong. That if the hair is acid, then the little hair, what do you call these?
Cuticle.
The hair cuticles close up, and if they're basic, then they open up.
Alkaline will open up and get through the cuticle into the cortex. That's how like in perming, we use an alkaline to get into the cortex. That's where all the action happens. Just like in coloring, we've been learning coloring this week. The higher the volume, the higher the alkaline, the more we're going to be able to change the cortex. And in here, this is the cortex. This is your melanin. This is the color. This is what I was talking about, underlying pigment, where the oranges, the reds, all are in here. So when we alter the cortex with color, that's what we're affecting.
So you treat alkaline to get the color in, and then you put an acid to close it up.
Yes.
And that's pretty much how it works. But the problem is you don't want too much alkaline or too much base.
Correct.
So we want to take a look at what is pH. So I'm going to give you a big one here. All right, you ready for this? You better hold on to your seats, okay? You hanging out real good? Okay. pH is the negative log of the hydronium ion. Woo! Holy moly's, what is all that? Well, the pH scale came from a guy named Soren Sorensen in 1909. He devised a scale that went from 0 to 14. And 0 is very, very acid, and 14 is very, very basic. So now we need to look at some other things here that probably might, and you might have to look at some other things here you might have some questions on. Okay, ions. Let's take a look at a hydrogen atom here. All right, a hydrogen atom is the simplest of all atoms. It has one proton in the middle and one electron. That's it. Now, if it loses that electron, all right, it becomes a hydrogen ion. So basically, any atom or groups of atoms that have either lost or gained electrons become an ion. They become a charged particle. Now, water itself is neutral, and there are rare occasions when water does separate into a hydrogen ion, and this little baby here is called a hydroxide. All right? H plus, this is your acid, your hydrogen ion, and OH minus, hydroxide, that's your base ion. Now, the hydrogen ion doesn't like being alone. You know, it's really lonely in there. So what it will do is it will link up with water to form what's called a hydronium ion. And that's an H2O with an added hydrogen, so now it's H3O plus. Okay, so that's the ion part of this. So you've got hydronium, which is just water with a hydrogen ion attached to it. And then you've got ions at each particle that's either lost or gained electrons. So now we got to deal with logs. Now, logs are ways for scientists to write very big numbers very small. Now, a log is simply if you have a number with base 10, all right, and it's the exponent of base 10. Now, like for instance, if I have 10 to the first power, okay, the log is 1. 10 to the second power, the log is 2. 10 to the third power, the log is 3. 10 to the fourth, 4. That's it. Okay, that's all it is. All right, logs are just the exponent of 10. It's just a way, so I could write, if I write log 6, okay, I'm talking about 1,000,000. So much easier than writing 1,000,000. And if you get in billions, trillions, and quadrillions, it's much, much easier. But the pH is the negative log. Whoa, where did that come in? Well, that means that when you stick that number for the pH, it slips into the bottom of the fraction. All right? So now, when you look, I'm going to give you these. Now some of these guys back. So if you take a look in the bottom, it says, why do we use logs? All right. Well, the reason we use logs is the pH is what's called exponential. In other words, every time there's a change in pH, its value goes up by 10. So if I go from 6 to 7, 7 is 10 times more basic than 6. 8 is 10 times less basic than 9. So there's always a factor of 10. So look on the bottom, just look at the highlights on the bottom. You got pH 3. Everybody see it? It's highlighted on the bottom. All right. So a pH 3 is 1,000. That means 1 in 1,000 particles. But you go up to pH 6, that's 1,000,000th. 1 out of 1,000,000 particles is a hydrogen ion. When you get up to pH 9, it's 1 in a billion, and pH 12, it's 1 in a trillionth. So in order to write these really big numbers very easy, we use logs. Instead of this, which you see, which is really complicated, we just write the numbers 0 through 14. But now at least you have an idea of what they mean in the pH scale. So another thing I wanted to show you is a little bit about acid reactions. And here I have some hydrochloric acid. It's not terribly strong. It's probably about the strength of vinegar. And I've got, this is universal pH paper. It's pH hydrion, and there's a little scale here that you can see, so when you do your measurements, you look at your scale and see what you get. So I'm going to put just a touch of this on here. And you can see it gets pretty red. So there's a strong base. Now here I have a seashell. This is a scallop. I'm going to put a dollop in a scallop. This is put this on here. Now, if you look closely, but you don't have goggles on, so I don't have to do that. If you look closely, they're fizzing. So you kick it around. See the bubbles going on? So there's a couple signs of a chemical reaction, and one of them is bubbles. So you know something's going on. Now, a little bit about these things here. This is an oyster shell, and this is a scallop. If these organisms die along with corals and they get crushed together, they give you this rock, which is a limestone. All right? If the limestone gets metamorphosed under heat and pressure, it becomes this stone, which is marble. So all of these things, the limestone, the shells, and the marble are basically made out of the same substance, calcium carbonate, which reacts with an acid. Now, you remember, okay, what the acid did here? All right, we're going to take a look now. You can see there, not as red. Neutral, didn't change at all. And here, just a slight red. So what these things do is they're buffering. When you get excess of acid and you want to calm it down, you put in a buffer. And I believe you probably use buffers in your cosmetology program to buffer so things don't get too acid or too basic. So those are the kinds of things that reactions that happen. So I have a bunch of things up here that you can test. I'm going to give you each a strip, and what I'd like you to do is to dip it in and then take it so you're not touching the substance, all right? And then just break it off and then try it again, and then write down. I've got a little sheet here where you can write down what the substance was and basically what the type it is and the pH. So I'll just let you just pass these around. I'll give you an idea what we have. This is coffee. We have some lemon juice, some toilet cleaner, some battery acid. Whoa. This stuff here, can you tell me what this is? Rusk?
Oh, that is hair straightener,
Hair straightener.
hair relaxer.
This stuff is so powerful that all you have to do is dip your thing in, and the fumes will change. So be careful with that stuff. This is a little soft scrub with bleach. This over here is some Coca-Cola. Very good. This is some white vinegar, some bleach that's been diluted in water, some bottled water, and some palm olive that has been dissolved in water. Now, over here, if you want to check out some buffering things, I have some Alka-Seltzer, and you could crush up a tablet and put a little water in, very little water, because it's going to fizz up, and you can check the pH of that. Here's some Tums over here. Okay, I've got a little grinding stone, so if you want to grind them up, you're welcome to do that. So there's a little extra thing you can do, and you can check those out. So, do you have any questions at all? Anything about all the big science stuff over here? The ions and the logs and, okay.
All right, does anybody have an idea, like, say, let's just throw an item up there, what the pH of the water would be? Anybody? Yes, who said 7? Very good. It's neutral, okay? Anybody think maybe what the pH of the battery acid would be? Well, you'll find out. Any guesses on any of the items up here with the, what do you think Coca-Cola would be?
9.
A 9? All right, why don't you come up and see? Grab a paper, let's see what it is. A 9, Renee? Go ahead, come on up, please. How many of you guys drink Coca-Cola? All right, let's see what the pH is. Let's see what it's doing.
Just take a little bit here,
Huh?
dip it in,
I'll get it.
and compare it with the scale. Now that Coke's been setting for a while. Now, Coca-Cola, what do we get?
About a 4.
Okay, 4, so it's a little bit on the acid side. Coca-Cola gets its acid from carbonic acid. That's what gives you a little burn in your throat. Now that Coke's been set out for a while, so the carbonic acid tends to leave. So it's like anything, we say soda goes flat. Well, that's kind of about where that is. So it's probably a little bit, if I'd been better at this, I would have done it right off the bat and then have you test it. But I did. And I did one right off the bat, but I think it came out basically the same, so I don't think it's flat yet. So, do you want to have students come up? They can each take a strip and go around and test things and take your readings. All right, so there's a strip of pH paper here, and come on up. If you need more, I'll put some out.
You know what I think? I think what would be good to do is, let's start with Caitlin. Caitlin, why don't you come up and you test the coffee? This is coffee, correct?
Yes.
Okay.
Coffee with cream.
Coffee with cream. So as you can see on this thing, if it is a pH of a 0, it comes up red. If it's a pH of a 13, it comes up purple. I'm going to pass this around so you guys can see. So when you come up and you do the litmus paper, you're going to see where you're at. That's how the colors go. So on 1 or 0, it's red, and then it goes almost to orange, or red-orange to orange, and it gets lighter. So, Ramanda, why don't you just come up and let's see what lemon juice is. What was Coke? I mean, the coffee.
It was a 5.
It's a 5?
Yeah.
All right, what's the lemon juice? You gotta open it up, yeah.
So we have a scale on the board, and as students do their check, they're going to mark it on the scale as to where the pH lies.
Okay, so
By the way, a
that's
little
lemon.
sidelight. Anybody know what the pH of your skin is?
So lemon is like a 3. You see?
What do you think?
6. I said here.
So it's like
It's about, from what I understand,
It's
it's
definitely an
about,
acid, okay? Lemon is definitely acid.
from what I understand, the pH of the skin is about 5.5. Now you might wonder, why is your skin slightly acid? Well, you probably don't want to know the answer to that, because when you sweat, you're excreting uric acid. The same acid that's in your urine comes out on your skin, and it is an acid, and it will lower the pH. So there you have it, something you probably didn't want to know.
Elizabeth, I want you to test, this is toilet cleaner. I had called down to maintenance before Jim came, and I wanted Drano, and he said that they don't really have, it's something like Drano, but it's more of an organic. So I wanted something to see if it was strong. Now the pH in some of your hair relaxers are as strong as Drano. So when you're using a hair relaxer, Drano eats the hair. That's how it unclogs drains. That's how strong your hair relaxers are. That's why you really have to respect. Oh, look at that.
Your
Okay.
Your hair relaxers are as strong
You
as
see how deep that is? So if you look at this, this is more like a 12. Okay, so this is toilet cleaner. That's how strong it is. See how deep that is? All right, Tessa, why don't you come up and test the battery acid? Okay, so this is toilet cleaner way over here. So now she's got the battery acid, okay? Wow, now look how red that is, okay? Remember I was telling you? Battery acid actually is the pH of it's like a 1. Okay? You would think it'd be the opposite. That's how I was thinking, battery acid, but it is acid and it is a 1. So go ahead.
Battery acid is sulfuric acid is what they use. It reacts with the lead in there, make lead sulfate, it gives you some electrons, and that's what powers it. One sidelight I want to put on, you might wonder, here we talked about the hydrogen ion and the hydronium ion, and you might ask, well, what produces these? Well, I got news for you. Your stomach. Your stomach produces lots of this hydrogen ion to produce hydronium ion, and it's an acid in your stomach because some of the enzymes, the chemicals in your stomach, work better in an acid environment. So, if you've ever got a really acid taste in your throat for whatever reason, the reason for that is you've just got some hydrochloric acid up there, because it is very strong in your stomach. So that's where you find hydrogen ions.
Okay, Des. I want you to test the neutralizer. Now this is neutralizer that we use for after perming. So first we break down the hair with the perm solution, and this is called, in other words, a fixative. So the perm solution is alkaline, it breaks down the hair, forms it around the perm rod, and then the neutralizer closes and keeps that hair in that formation. So that's how it works. So let's see what neutralizer is. Okay. See, it's definitely an acid. I would say it's like a 4, right? So neutralizer is a 4. Hey, Deb, could you grab a perm solution in that cabinet? Do you know where it is? Okay, so neutralizer. Who's next? Emily, can you come on up here, please? Now, remember how I got this out the other day and you guys could smell it almost from my desk? This is that hair relaxer that is so pungent. And you can smell it without even opening up the jar. Let's see what that is. That's definitely right about, I would say it's like around a 9 or an 8. No, it's getting darker. I would go with a 9. So this hair relaxer is definitely a 9. Okay. Emily, do you know where a perm solution would be? You don't have any in there? Did you look in the dispensary for me? All right, thank you. All right, so this is a 9, all right? That's strong. All right, what else do we have here? This is salt. What is this here, Jim?
That says soft scrub.
Soft scrub.
That's a
Okay. Who's next? Amanda, why don't you come on up here? please. Thank you. So this is soft scrub. This is what your parents or people use to clean their bathrooms with, okay, or their ovens. Yep, that one, please. I would say that's close to a 5, right? Okay, thank you. So that's close to a 5. And what do we have here? So we did the Coke. Vinegar. Okay. Emma, you want to come up here and check out the vinegar, please? Thank you. Just take one of those. And there's vinegar, right? Yep, just dip it in there. Let's see what it is. And now let's look at the scale. It's pretty yellow, right? I'd say it's like a 4, maybe. It's pretty yellow, so it's more like, yeah, I would say it's a 4. Okay, thank you. So vinegar. I spelled that right. And what else do we have here? Bleach. Mira, can you come up and check out the bleach for me, please?
That's a diluted bleach I added. I didn't put it in straight, so it might be a little weaker than regular bleach, but it just smells a lot better.
Right here. Oh, that's definitely, what would you say? Close to, oh, it turned green and then it changed. So maybe that's because it is diluted. You see how she's got a green stripe there and then it weakened?
Try a dip again.
Yeah,
Tear that, yeah. Just put it in and see what we get.
Okay, so it did it again. Isn't
Did it
that weird?
again.
Yeah.
So it's interesting in there because you have a very strong layer of base right near the top that's forming a layer, and then the bottom is less basic.
Yeah, because it's making a line. That's weird.
Yeah, definitely making a line,
It's
yeah.
an 8.
That's it.
Yep.
Yeah. So sometimes you think acids and bases just mix, just simply mix, but sometimes they don't, and there's a good case of it.
I'm so short. All right, so what else do we have here? Water. Ramonda, will you just come up and check out the water? We all know what it should be, right? What should it be?
7.
Yes, it's neutral. So you ever look in the ingredients of something that you're using, and if water is listed first, you are most likely working with a neutral product. Yep. I'd say it looks more like a 6, this water, don't you think?
Yeah.
Yep. So I'm going to put it in between 6 and 7. I think it depends on the water. All right. So do we have any more? We have
Palm olive,
palm olive.
little diluted palm olive. That's,
Okay, come on up, Caitlin. Thank you.
Dish detergent.
Yes. What do we got here?
And there is a little green color in it that
Yeah,
palm olive
I'd say,
puts
yeah.
in.
I'd say like a 6. It's getting a little darker. Yep. Okay, dish detergent. So as you can see on the board, how everything varies. So imagine if something was a 14. Do we know what would have a pH of a 14?
Very strong, like hydrochloric, sulfuric, nitric acid, could be a 14. You can actually have acids that are higher than 14 and bases that are higher than 14 and acids that are lower than 0. They actually exist. The scale came up as it's convenient because most substances will fall in the 0 to 14 range.
Okay. Does anybody have any questions at all? No? Okay. Do you have anything you want to add?
If you have no questions, and maybe next time, if you want to learn about science, where do you learn it from? Science in the Valley. So we'll see you until next show. Take care.